Prasar presents a series of biographies of the great Indian scientists. Ever since India's interface with the rest of the world, there has been a major field where she has risen to towering heights of excellence with her valuable contributions: science and technology. Our motherland has given birth to some of the greatest thinkers and scientists of all times, who have led forward the thread of technology to new and innovative limits. This is an inspiring and interesting story about their achievements and struggles, their recognitions and laurels. So friends, let's delve into the lives of these great Indian scientists who have lit up our rich history with their unmatched examples. A journey through our fictional characters which will relive the golden times gone by. Today's episode is about the life and contributions of Vikram Sarabhai.
Uncle, this looks so fabulous.
Sarah, this is a model of INSAT 1A. Any idea what INSAT 1A is?
Isn't it the short form for Indian National Satellites? INSAT 1A was launched on April 10th, 1982.
Good, Sarah. I'm amazed by your knowledge. Now tell me, who is considered the father of Indian space program?
No luck.
Well, it was the legendary Vikram Sarabhai who dreamt of self-reliance in space technology and worked hard towards that dream.
I know of another Sarabhai, Malika Sarabhai the dancer. Are they related to each other by any chance?
There you are. She is Vikram and Malini Sarabhai's daughter. They established Darpana, an institution devoted to performing arts in Ahmedabad. Sarabhai was a man of deep cultural interests. Oh, we have to meet Mani. He promised he would wait for us inside. He can tell us more about Sarabhai. He is a curator over here these days.
You are truly great, Bhanu uncle. You have such resourceful friends.
Good morning, Bhanu. We are meeting after a long time.
Good morning, Mani. Meet our friend, Sarah.
Hello, Sarah.
Oh, Sarah, is Jayati coming? I told her to reach museum straight away.
Hello uncle. We were just talking about Vikram Sarabhai. We are eager to know more about him.
Hello everybody. Good morning.
Hello, Jayati. Mani, Jayati is also one of my friends. She's also interested in visiting the museum.
Hello, Jayati.
Hello uncle.
Okay, let's go to the cafe and talk. Later, we will visit the museum.
Yeah, let's discuss the history of Indian space science over a cup of coffee. Sarah, what will you have?
It is really hot, uncle. I will have lime juice.
I think I will also have lime juice, uncle.
Sarabhai was a rare combination of an innovative scientist, forward-looking industrial organizer, and imaginative builder of institutions for the economic, educational and social upliftment of the country. The fields he laid his hands ranged from nuclear power and electronics to textiles and to performing arts.
It seems great minds do not restrict their talent to one field. They always seem to be interested in a variety of areas and fields.
You're right. By the way, tell us something about Sarabhai's childhood and his early education, Mani.
Vikram Sarabhai was born in 1919 to a wealthy family in Ahmedabad. He did his schooling in the school run by his mother on the Montessori line.
In 1920s, such schools must have been a rarity. Sarabhai was really privileged.
He got his tripos in natural sciences in 1940 from Cambridge University. Later he did his PhD on cosmic ray investigation in tropical latitudes from the same university.
I think shortly after doing his PhD, Sarabhai helped to establish Ahmedabad Textile Industries Research Association. Remember, he had no formal training in textile technology. It was really an important step towards modernizing textile industry in India.
Oh uncle, Ahmedabad is the hub of textile industry in India, right?
Absolutely.
Uncle, how did he get involved with the atomic energy and space technology programs of the nation?
After the death of Homi Jahangir Baba in January 1966, Sarabhai was made the chairman of Atomic Energy Commission.
Sarabhai was behind the establishment of Faster Breeder Test Reactor, Kalpokkam, and Uranium Corporation of India Limited, Jadugoda, Jharkhand.
Mani uncle, I think I have heard about it. I think UCIL was criticized for producing hazardous nuclear waste, risking the health of local people. I read about it in the newspaper some time back.
You know too much. I think if Sarabhai was alive now, he would have been equally concerned about nuclear waste as he was about the immense potential about nuclear energy.
Here's your lime juice, Jayati. Tell me what you want to be. I'm sure you identified your career.
Yeah, uncle. I'm planning to do my MBA. Long way to go before that. But I think I want to do an MBA from one of the IIMs, preferably Ahmedabad.
It seems Sarabhai will not leave us. He was the pioneering force behind the establishment of IIM Ahmedabad.
Oh, I didn't know that. He's just wonderful to know about.
Tell me about his work on space technology and research. I believe as a developing country, India should concentrate on eradicating poverty rather than sending satellites into the space. What do you say, uncle?
This was the point raised by the detractors of Indian space research in 1960s. But Sarabhai saw no contradiction between the national goal of poverty eradication and space research. On the contrary, he saw them as complementary. He believed that the selection of a field of scientific activity should depend upon the contribution it can make to the defined national goals.
Makes a lot of sense. But what contribution can space research make to the nation?
Sarabhai identified 3 specific applications for space research in India: remote sensing, communication, and meteorology. These remain the cornerstones of space research even today.
I believe satellites help in more accurate weather forecasts and through that in agricultural production.
Exactly, you get the links really well. I'm really proud of you.
More importantly, satellites facilitate communication, which constitute a good part of the economic activity in the nation.
Oh Mani, tell us about Thumba Equatorial Rocket Launching Station.
It was Sarabhai's persistent efforts and vision which gave shape to the Thumba rocket launching station. Initially only lightweight rockets were launched, but later the weight increased as well as the number of subsystems and components used.
Where is this place called Thumba, uncle?
It is in Kerala, on the outskirts of Thiruvananthapuram. It used to be a sleepy fishing village. Thumba Equatorial Rocket Launching Station was started near a small church, which is now a space museum.
It must have been really difficult to set up the station initially.
Initially, the scientists had to work with bare minimum facilities. The first launch in 1963 saw some anxious moments. The scientists operated from church building, and when the rocket was about to be placed on the launcher, the crane developed a leak and the scientists had to lift the rocket manually using their collective muscle power.
I never knew that India's space research had such humble beginnings. By the way, I think my grandmother is from Velli, which is near Thumba. I've heard her saying a lot about those times, how she used to wait anxiously to see rocket launching. She says it used to be a spectacle she and her friends eagerly waited for.
Oh, is it? I never knew Mariam Auntie was from Thiruvananthapuram. How is she these days?
Her arthritis is troubling her a lot, but she manages quite well.
Mani, tell us something about Vikram Sarabhai's role in the development of Indian satellite systems.
Well, in March 1970, Sarabhai worked out the broad details of an Indian national satellite system, now known as the INSAT system. This was the time when India started examining feasibility of a domestic geostationary satellite system. Sarabhai's paper suggested that India should procure the first set of satellites from abroad and build the subsequent sets in India.
So that in the genesis of the famous INSAT series.
In 1975, a committee suggested a 3-in-1 satellite concept. That is, each satellite will provide telecommunications, television, and weather data.
I think the Indian space program has been application driven right from the beginning. Sarabhai had a clear-cut strategy in his mind. He did not want to wait till India made its own satellites. Rather, he procured foreign satellites so that the application could be proven, ground system could be put in place, and where scientists could be familiarized with the new technology.
I think that is very sensible. That shows real practical wisdom.
I think Sarabhai also played an important role in making India's pharmaceutical industry self-reliant and self-manufacture of many drugs and equipment in the industry.
A lot of interesting facts on this subject would be disclosed by Sara, Jayati and her uncle Bhanu. Keep on listening to Biographies of Indian Scientists.
Ham radio popularization is a major activity of Vigyan Prasar. Vigyan Prasar, jointly with National Council for Science and Technology Communication, NCSTC has established an amateur radio club, VU2NCT. The importance of ham radio cannot be overemphasized during the natural calamities like floods or earthquakes.
Welcome back. You are listening to Biographies of Indian Scientists, a series presented to you by Vikram Sarabhai.
Uncle, you told me he was a connoisseur of arts. What were his interests in this field?
He was interested in music, photography, archaeology. He was a real visionary and an all-rounder.
A true genius.
He died on 30th December 1971 at Kovalam, a tourist spot near Thiruvananthapuram, at the age of 52.
His untimely death was a major blow to the Indian space program.
How does the science fraternity remember him? Uncle, is there something in memory of him?
Yeah, very much. In 1974, the International Astronomical Union at Sydney decided that the moon crater in the Sea of Serenity would be known as Sarabhai crater.
How appropriate. What a romantic way to remember a visionary.
Come Bhanu, Sara Jayate. Let's move into the museum. There we can see more models of rockets and memorabilia of the Indian space program.
Uncle, could you tell us the various institutions established and looked after by Sarabhai as an institutional builder in India?
Physical Research Laboratory, Ahmedabad. Indian Institute of Management, Ahmedabad. Community Science Center, Ahmedabad. Faster Breeder Test Reactor, Kalpakkam. Variable Energy Cyclotron Project, Calcutta. Electronics Corporation of India Limited, Hyderabad. Uranium Corporation of India Limited, Jadugada, Bihar. Vikram Sarabhai Space Center, Thiruvananthapuram. There were many other institutions which had been established by him all over the country. I think it is not the time to describe each one of them.
What happened to the Indian space program after his untimely death?
After his death, Professor Satish Dhawan, then the director of Indian Institute of Science, IISc, Bangalore, took over the charge of the Indian space program. In June 1972, the Department of Space and Space Commission was set up and ISRO was brought under the Department of Space. If the Indian space program owes its birth to the vision of Sarabhai, it was Professor Dhawan who gave muscles and sinews to the programs.
Can you please tell us how Indian space program developed through the years, Uncle?
In my opinion, it is very difficult to tell you all in a sequence.
That is correct. You please begin with how it was developed. Later, if they have any doubts, they can ask me and I think I will be able to clear their doubts. But please go ahead with that, what you're trying to say. It must be interesting, I'm sure.
The Indian space program, which commenced with the launch of a tiny sounding rocket acquired from National Aeronautics and Space Administration, NASA, of the United States in 1963, reached a high point when Indian space scientists successfully test-fired a 401-ton Geosynchronous Satellite Launch Vehicle, GSLV, the massive ever rocket to blast off from the Indian soil from Sriharikota Launch Center on April the 18th, 2001. With the success of the first developmental flight of GSLV, it meant that India achieved the capacity to launch communication satellites as heavy as 2000 kgs into an orbit of 360,000 km height, realizing the dream of Sarabhai, the father of Indian space science, of achieving self-reliance in space technology.
Oh, and what are the satellites India placed in the orbit?
Well, Jayati, I'm not sure about it, but I think currently India has 6 Indian national satellites, INSAT satellites, such as INSAT 3C, INSAT 3B, INSAT 2E, INSAT 2DT, INSAT 2C, and GramSat, which is placed in orbit by the maiden flight GSLV in geostationary orbit.
What is the use of placing these satellites in the geostationary orbit?
See, Sarah, these multi-purpose satellites provide communication, broadcasting, and meteorology service. Except GramSat, all other satellites were launched by European space agencies' Ariane rockets from Kourou in French Guiana.
Uncle, what were the difficulties that we had to face while making missile technology?
After a few years, scientists realized the importance of developing and producing suitable propellants for the rocket program. Propellants which supply energy to the rocket are generally divided into 2 classes, solid or liquid. While sounding rockets generally use solid propellants, heavier satellite launchers use combination solid and liquid propellants. While solid propellants are relatively easy to produce, they have an inherent disadvantage. They cannot be switched off once it is ignited. On the other hand, liquid propellant technology is complex, but the energy efficiency of liquid propellant is very high.
Well, Uncle, what role did Sarabhai play in developing Indian Space Research Organization?
Let me answer this question, Mani.
Of course, it seems that we have almost covered this museum. Now we can move out of this place and sit outside. If anyone needs coffee or tea, I can order for that.
We can have that after some time, Uncle. Anyway, this is the time to have lunch. I'm really hungry. Isn't everyone?
Yes, we can move out of the museum and sit outside. After some time, we can have lunch.
Uncle, please answer Jayati's question first. I am eager to know.
ISRO, initially formed as a part of Department of Atomic Energy in August 1969, to commence work on a satellite launch vehicle. Sarabhai had taken over the mantle of DAE following the sudden demise of Homi Bhabha in a plane crash in 1966. But a satellite launch vehicle was much more complex than a rocket. Unlike a rocket, which has to carry its payload till the fuel is exhausted, a launch vehicle has to have complex guidance and control systems so that the satellite is injected into a desired orbit. Besides this, it needs to have multiple stages of propellants.
Wonderful, Bhanu. I am certainly amazed the way you explain the facts. The Indian space program's greatest asset has been Sarabhai's vision. In the early and mid-60s, when applications using satellites were in experimental stages even in the United States, Sarabhai was quick to recognize their benefits for India. He foresaw that satellites could usefully supplement ground-based systems for providing many services in communications, direct TV broadcasting, remote sensing and meteorology. Sarabhai chalked out a strategy to achieve the Indian space program based on application driven right from the beginning.
Is his vision still leading ISRO? Or is it something else?
I think so. Professor Dhawan's initial years in ISRO, a number of programs were initiated. Designing and development of indigenous satellites and various projects in space applications were some of them. Just before he took over, India had entered into an agreement with the erstwhile Soviet Union for launching a satellite that ISRO was planning to build indigenously. This was later named after Aryabhatta, the famous astronomer mathematician who lived in India in the 5th century.
Mani, have you started saying the space history?
Are you getting bored?
Certainly not.
Well, as far as this concerns, we can learn a lot more from Professor Dhruv Raina. Professor Raina is a professor in JNU. Let's talk to him.
Vikram Sarabhai also belongs to that constellation of Indian scientists who did first-class research, but also dedicated their lives to building institutions where first-class scientific research could be pursued, not only for the sake of science and for understanding nature or for satisfying our curiosity about the world, but also in order to ameliorate human suffering, to ensure that India catches up with the developed world. Like Bhabha, in a way, there are parallels with Bhabha, of course. Vikram Sarabhai started off his research career in the area of cosmic ray physics and pursued observations at high altitudes, particularly in Gulmarg. But the other parallel with cosmic ray with Bhabha is that he was studying at Cambridge, and then World War II broke out, and Bhabha had finished his PhD and come back to India, and then when World War II broke out, he couldn't go back. And then Sarabhai could not go back for some time to do his PhD. And although he was awarded his degree by Cambridge, he did his work under the supervision of C.V. Raman in Bangalore. In addition to his contribution to cosmic ray physics, which were very fundamental, I think we should see how cosmic ray physics played an important role in enriching the repertoire of technological skills of Indian scientists, of physicists who were working in cosmic ray physics in India, subsequently also developed the skills of working with the telemetry, and they graduated into looking into the regime of space technology and space science. So from cosmic ray physics, they seem to have graduated into telemetry and space science, from where then we get the whole question of applications of satellite technology for television and the SITE program and a number of other areas. So in a way, Sarabhai is certainly also the father of the space program in India, which was subsequently developed by Satish Dhawan and others. But I would also like to see this foray into space science, from cosmic rays into space science, as also seeding a lot of secondary development, in the sense that it just did not seed a development in the world of scientific research, but also promoted the whole electronics industry, which emerged as an auxiliary industry to the space program. This was a secondary contribution which is associated with this generation of institution builders in science, that not only did they build institutions of science, but the building of these institutions of science also seeded off secondary activity in the area of industry and enriched the quality of industrialization in India, especially in areas of frontier technologies. Sarabhai, of course, in addition to playing this whole role in satellite communication, space science, and the space research program, also played a very important role in the textile industry of Ahmedabad and in Gujarat. He also saw the tremendous role management science would play in the future of industrialization in India. And so there are several other aspects of his life where his visionary contributions are evident even today.
So, Sarah, that was really interesting information, wasn't it?
How fascinating.
When was Aryabhat launched, Uncle? Had it been a successful effort?
Almost true. The task of building this satellite with a unique structure with 26 faces and a weight of 350 kilograms was given to a team of 200 dedicated scientists and engineers led by U.R. Rao. These experts, drawn from organizations such as the Hindustan Aeronautics Limited, Bharat Electronics Limited, Electronics and Radar Development Establishment, Indian Institute of Science, and other private companies, worked day and night for 2.5 years to make Aryabhatta ready for launch from a Russian launching facility on April 19, 1975.
And what was the second effort in this respect?
Well, Jayati, the Bhaskara 1 and Bhaskara 2, two Earth observation satellites, were launched from Soviet Union in 1979 and 1981, respectively. These satellites, along with Rohini satellites, which went aboard the SLV-3, were the precursors of the operational Indian Remote Sensing IRS series of satellites.
Well, Uncle, what is SLV-3?
Jayati, SLV means Satellite Launch Vehicle. I think I mentioned it earlier also. 3 refers to this series only. SLV-3, an Indian SLV, thus planned, was to have 4 stages, all powered by solid propellants. Sarabhai handpicked 4 young scientists working with him to entrust the task of designing each of these stages.
And who were these young scientists?
Well, Jayati, the scientists who were picked up by Sarabhai were Govarikar, Muthu Nayagam, M.R. Kurup, and APJ Abdul Kalam.
APJ Abdul Kalam, the President of India now.
Yes, Sarah. What happened to you? It seems that you are very much interested in his story also.
Okay.
I will tell you very briefly. APJ Kalam, who before being elected as the President of India was a chief architect of Indian guided missile program and later the scientific advisor to the Defence Minister and head of the Defence Research Development Organization DRDO.
Uncle, it is really exciting to know about Sarabhai. Both of you are great storytellers. Thanks a lot. But I'm in a hurry. I want to eat something urgently.
We are also coming, Jayati. Relax.
Okay then. I will wait for you at the hotel.
Thank you, Uncle. It was really a good story. I will try to read something about Sarabhai after my exams. Thank you for inspiration. I really enjoyed myself.
Thank you, Sarah.
Thank you, Mani. You have spent a lot of time with us.
It's okay, Bhanu.
Jyoti will be waiting for us at the hotel.
For further information and to know more about this program, please contact Director Vigyan Prasar, C24, Qutub Institutional Area, New Delhi 110016. Presenters of the program are Jayati Roy, Devjit Acharya, Sara Hashmi, Parvesh Haryani and Nisha. Research done by Dr. Subodh Mohanty. Script Jayati Roy. Editor Anil Kohli. We are thankful to Dr. V.B. Kamble, Shri Biman Basu, Dr. Dharm Prakash and Dr. Irfan Habib for their warm cooperation and resource input. The program coordinator is Dr. T.V. Venkateshwaran. Director of the program is Subhash Kapoor. The program was produced by Vikalp Communication Private Limited for Vigyan Prasar.